Hello and welcome to another episode of, I was about to say Hermitcraft. I've been watching that too much. Another episode of Neptune Lander. Now, in this episode, what we're going to try and do is, at the moment, Neptune Lander's controlled by the joystick. But I want to give the opportunity for the user to choose how they're going to control it. The reason for this is because I'm already thinking about Hunchback now and how we're going to do dual control. So I thought I'd try it here on Neptune Lander and iron out all the bugs and everything. So what we're going to do is when the game starts, we're going to give the person the opportunity to choose which controlling mechanism they want to use, and then we will then use that result to control what happens to the lander. So be prepared. This could be a long one because I've got a few things I want to show and then explain why I've come to the conclusion of doing the way I'm going to do it. So the typical way of using the keyboard. Now, spoilers. Just showing a screen that I didn't want to show, but never mind. Spoilers. Where are we? Where is it? Let's minimize that. Right, so here we are in Vice, and the normal way we check for a keyboard. So let's do it here. So we're going to print, and we peak 197. 197. All right. So this is listening to the keyboard. This is the kernel's end result to the keyboard, right? So if I press A, we get 10, yeah? And if I let go, we get 64. If I press B, we get 28. So this is the kernel's way of deciphering the keyboard matrix and to then return it as a number. The problem is if I press A and then press B, I lose the fact that I've pressed A. Yeah? So if I press B and then press A doesn't even respond. So, and that's because that's 10. So if I press I, which is 33, and then press B, now B is not shown. And that's the problem with using this 197 thing, is if you think about it, in Neptune Lander, we're going to want to press the thrust as well as direction at the same time. But peaking 197 only gives you the first key, or the highest value key number, I should say. And that tends to cause problems because it only means that you can either go left, you can either go right, or you can either slow down. You can't slow down and go left at the same time like we could do with the joystick. So we have to find a different way of doing this. And so the way to do it is to actually interrogate the CIA itself. And the way to do that is we talk to those chips. And that's why I had the other Vice open. So here we are. I've written this little program based on a screenshot that I saw on CSDB, I think. And basically, this, what you see on the screen here, this is the keyboard matrix. So you have to try and visualize. In fact, we'll not try. Let's see if we can find it. Let's bring the browser in. Let's see if we can find it. Alright, so C64 keyboard matrix. Here we go. And let's see if this one is the better one. Here we go. So the keyboard's connected to a connector that feeds the CIA chip on 2 of its ports. And that is represented in a 64-bit matrix setup. And what happens is, see if we can find it. No, not on there. Back out. See if we can find an actual diagram of the keyboard matrix. I wonder if that's it. Oh, it's the same place. So where's that picture then? I was wanting that picture. Never mind. Let's see. Come on. Can I zoom into that? No. Oh yes. I can. There we go. And so what's happening is we've got 2 control ports that we're going to use on the same CIA chip. And what we do is on control port 0, or A, I think it is, control port A, we set that port to be an output. So it's going to send an output. And then control port B is going to be an input where we listen, and so we set it up to be an input. And then what we do is we send a signal through the keyboard, and then we listen to see if we get a response. And if we get a response, then we know a key's being pressed, and so we can then check what line it was when we sent out and what the line was when we sent back. So basically what I mean by the line is when we send out the signal on control port on port A, we only send out 1 bit and that is 1 line gets made high. And then we listen on port B for a bit, and the bit then corresponds to where the key's been pressed and then completed the circuit. And the beauty of this is it allows you to listen to the keyboard across the board. So we can then, as I will demonstrate now with this program, is we can then detect more than 1 key. So if I do the same thing as before, if I press A, there you go. So that's basically saying that if I send an output on bit 2, basically, bit 2, line 2, or bit 2, on the port A, and then we listen here, it comes back on bit 3 on port B, and that's how we listen to it. So if I press B, that's now on line 3 sending out, and it's coming back in on line 4. But the beauty of this, if I press A and then B, look, we can test both keys. And if I do the same by pressing I and then B, we can see both keys. And if I press A as well, there's A. And if I press L, we get 4th. And we can test multiple presses. So we can test whether the thrust has been pressed, which is that, left or right. And that allows us the great flexibility of doing this. The downside is we've got to constantly scan the CIA chip to get the complete matrix. So we get the matrix, then test it, get the matrix, then test it, and constantly scan. But that's easily done. So, question is, I have now got to remember where these are. So, if this diagram is right, that diagram is right. Let's move that over there a bit. And move this over here a bit. I think that's about working. Then let's see where. So A. So this is line 1 onwards. So we're talking from line 3 onwards, and same here, yeah, because this is the matrix that we're only interested in. So where was A? Where was right? So I'm thinking of greater than, less than. So that's line 5 of DC, which is probably this one. In fact, that's the jump. Let me look at that one. That's probably a better one to look at. There we go. Let's bring that up here. Right, so if it's A, B, C, D, that's the columns, right? And the rows. So rows is here. Oh, that's all screwed up. But we can still work it out. So greater than and less than is on the row 5, which is here. And it's actually comma and full stop, which are these two here. Yeah? Now, we are, if I move over, 0, 1, 2, 3, 4, 5, 6, 7. So we're on line 3. So these two are on the same line, which were right, and 1 and 4. This doesn't make sense. Doesn't make sense. Yeah, they got it the other way around. Got it all the other way around. Let's shift that over so we can see it. Right, so it's on the same line of A, yeah? So it's on line 5. So 1, 2, 3, 4, 5. 5. That's there. 7 and 4. That's not right. Oh, it is. 7 and 4. 7 and 4. Put 7 and 4. That's confusing, isn't it? When they don't line it up right. So 7 on line 5 is the full stop. So I'm going to press the full stop. There you are. So, which is 5. And then 5 and 7. So 5 and 7. 5 and 7, that's 5 and 7 is the full stop. And then that's the comp. Oh, back up. So space, there is 7 and 4. Hey, 7 and 4. Wicked. Right. So all we need to do is write a routine to read this keyboard scan and then use it within Neptune Lander. Easy said and done. But we'll have a go. We'll have a go. So let's fire up Neptune Lander. Get rid of all this. So what we need now is we need a library to scan the keyboard. Yeah. Let's see. So we haven't got it in here. Okay. Then we'll write it. So what we need to do is we need then some variables up here. So keyboard and scan byte. And we are gonna do byte 0,0,0,0,0. So 1, 2, 3, 4, 5, 6, 7, 8. So that's going to give us our 64 by 64 matrix. And we also need a now we'll do that in the game memory. So let's have a think. Right, so there are the scan bytes. So what we need to do is we need a routine to scan the CIA chip. And yeah. Yeah. So scan keyboard matrix. So the first thing we need to do is we need to tell the ports what we want them to do, the directional ports. So let me load up mapping 64 so we can see what we're meant to be doing. Can you see that? Why can't I get rid of that? Ah, I can. That's better. Right, so mapping the 64. So we need to find DC00. No, next. There we go. Oh, look. I had one in here. Bit 4 and 5. Oh, no. Bit 7 and 4 on bit line 5. Oh, I was right. Oh, how cool. How satisfied am I? Hey? Right. So, what we're going to have to do is, this is port A. So this is port register A, and this is port register B, and they're the two ports that we're going to send out the signal and listen to. But we've also got to tell port A and port B what they are, and that's where DC02 and DC03 comes in it. So DC02, we're going to have to tell it it's a output. It's an output port, and to set the output we have to set it to 1. Okay, so let's go straight back here and do this. So let's do this. So LDX, so make it all 1, and then we store it in DC01. DC02. Okay, and then on DC03 we want to make it an input, which is 0. Okay, so LDX #0 store X DCO3. So that's set up the CIA to be an output and then an input on both of its ports. So now we have to interrogate those ports. So what we need to do is we need to go, okay, now let's change this. I need to have 2 different registers, don't I? So we want to send out the signal to DCOO, and Y is set to 0. So we're going to set every line to be active, to connect to every so we set it every line, every bit to be active, because remember, 0 is on, 1 is off. Don't ask me why. That's it. So we're looking for zeros. So we're setting 0, which means we're turning all that port on, and then we'll compare anything DCO1. So we're going to compare X. So it means is there any sort of activity? And basically, if because we're looking for zeros, if it's all 255, that means the key wasn't pressed. So what we're going to do is we're going to say branch if equal, and to say that no keyboard activity. So that's going to jump out. So let's go a bit further down, and we'll put this down here. Just put RTS for the moment, just to make sure. Now, what we need to do now is we need to turn off DCO1. So Y is, I'm doing it again. To turn off, we set them all. So it's X. So we store X into DCOO. That's going to turn the lines off. Then let's compare X with DCO1. So we're still comparing a signal. So we're comparing there's no activity, and if there's no activity, it's going to be equal. So therefore we need to branch not equal, because we've now turned off the line. So if we get something back, then that's got nothing to do with the keyboard. Yes. So we'll do the same thing again here. Right, so now we've got to scan the keyboard. So what we need to do is we need to set up our testing lines. 1, 2, 3, 4, 5, 6, 7, 8. And remember, let's put this down. 1 mean equals off, 0 equals on. So now what we're going to do is we're going to test each of the lines. We're going to test each of the lines and get the result back for those lines. All right. So we're going to store that in the output. Store a DC00. And then we're going to load back DC01, whatever the result was. So that's loading the result into Y. Alright, and what we need to do here is then store Y into, what have I called it? +7. Oops. Why's my numbers not working? Now they're working. So that's testing the first one, and then what we need to do then is we need to rotate that 0, yeah? So we're going to rotate it left so it goes up the byte, alright? So rotate left, we're going to store it back into DC00, we're going to load back DC01, get the result, and then we're going to store it into ooh, yeah, it's +6, isn't it? So I'm repeating this again. It's +6, and then we're going to do it again. So this time it's +5, 4, 3, 2, 1. Zero. Oh, there's a better way of doing that, isn't it? There's got to be a quicker way of doing that. There's got to be a quicker way of doing that. I can do that as, could do that as a, let's do that as a macro. It's got to be a quick way of doing this, right? So def lib input scan keyboard bit. So accumulator equals bit to scan and Y result. So result location. Okay. So the first one, we've got to start with that. So we could do that. Could do that. Because we're rolling, aren't we? We're rolling. Yeah, we could do that. We could do that. So this is /1 and M. Right, so we need to here clear Clary LDA hash on, because as soon as we do the macro, we are put that there. As So as soon as we do the macro, we're rolling it straight away. So we're going to put, and because I've cleared the carry, that's going to roll a 0 into it. Good. And then we just do it for the rest of them. So, so 6, 5, 4, 3, 2, 1, 0. Get rid of all that now. So we do all that, and then we need to do this again, because X we haven't touched. Yeah. Now, what we do need to do though is we need to initialize the keyboard matrix. So we'll do that here. LDY #0 store Y in, oops, undo, scan byte, comma Y, I and Y, CPY #8, branch is not equal to at clear matrix. Right, so this is lib input yeah. So this is now going to scan the matrix, and so we're clearing it out. We set it, we check for no keyboard activity, which is wrong because we need to. Good job, I spotted that, John. Because remember, everything's ones. Everything's ones. I don't think I can do store X, Y. There we go. Yeah, so we're storing ones. That's always a 1. No keyboard activity is 1. Okay. So we set for output. We set the second one, so this is port. Set port A for output. This is set port B for input. And check for activity. I'm not sure I need to do this. Yeah, we'll check for no activity. Well, don't need to do this. I don't think we need to do that. Why run through all this if there's no activity? Right, so it runs through, and then we don't need to do this either. But what we do need to do is we need to set the do we reset the state of the control ports? Because we set it, do we need to unset it? No, I don't think so. I don't think so. Right. That should be the keyboard input routine written. Yep, I think that's about right. So, what we need to do is we need to create another variable in the game memory. Input device. Byte 0. And what we're going to do is we're going to ask them, but if the answer is not 0, then we're not going to ask them again, because it means that they've died and they've gone through the loop, and we don't want to do that. So what we're going to do now is we need to go and find where the is it Lander? I can't remember. Oh, here we go. We could do it on the debug. Couldn't we? We could test it out on the debug. Yeah, we'll do that. So this is now the debug input routine. So what we need to do is we need to create another input routine. So this one is the joystick. So we'll copy that and we'll paste it there. So GL joystick debug input. Yep, and then we'll just do RTS from that. And so we'll put a test in here. So we're going to go LDA. What's the memory location again? Input device. So LDA that. Compare it with need a constant. Yeah, we're not doing peak 197s now. So let's put it in here. So keyboard, no, input device keyboard equals 1, input device joystick equals 2. So we're going to do this. So input, compare it with joystick branch if not equal to keyboard input, and we do JSR, no, jump, because this is a JSR, isn't it? Yeah. No, we'll do a JSR because we need it, and then we need to go. So JSR this, and then jump to at debug information. Okay. So then we go and jump to that. So now keyboard board. So now this is going to be here, and then we're going to go save that. We're going to call this. I'm calling that. So now we need to so we scan it and then we need to test. Right, so we are looking at, let's fire that let's fire that fire that C64 up again. Here we go. So the controls I want to use is comma and full stop. So we're looking, so if I press comma, so it's line 5. So it's line 5. And it's bits, so comma is bit 7 and full stop is bit 4. Space is on line, so space is on line 7 and it's bit 4. Right. We'll keep that running in the background. There we go. So now we've scanned for the keyboard, we need to check. So if we're going to check, so the first one is left, isn't it? So left is going to be comma. So we're going to compare so we're going to load the keyboard memory. Told you this was going to be a long one. Just going to load the keyboard memory +4. That's what we're hoping to be testing. And then we're going to be comparing it with this. So it's bit 7. One, 2, 3, 4, 5, 6, 7, 8. So we're comparing with that. So if it's equal to that, then we want to do it. If it's not, we want to do that. So that's left. So same thing again, but this time we're testing bit 4, 7, right, 7, 6, 5, 4. So that's testing that. Now we're not testing up, so we'll get rid of that because we're testing the fire. So we'll get rid of that. Oh no, that's right. So it's test fire. That's what we need to do. Fire. I'm going to show that it works with fire. Make it go up. Fire. So I'm going to make it go up. So we're testing space 7 and we're testing bit 4, which is already done. Don't need that. So that's making it go down. Okay, that's all right. So we need to initialize the input variable. So we'll do that here. Put it in demo mode and then go LDA hash ID keyboard. Store it in input device. Should do it. Let's just make sure. Yeah. Shall we try it? This is gonna break straight away. Well, I never. Right then, press fire. Easy. Now we should be in demo mode. Here we are. Right, I'm pressing the wrong keys. Right. Oh dear. Let's put some characters up. So let's do the first one first, which is input. That's joystick. Is this one? Keyboard scan byte +4. Let's see what that's coming out as. Told you this was going to be a long one. Right, so it's 255. We're getting back 255. Well, it's not even scanned byte 4. So we need to find out what byte number is being quite. Yeah. Let's load this up in C64 debugger. Have I got it set up? Yes. So, build program. Yeah. Here we go. So we want to look at the memory. I think that's shift 2, but I'm not sure where the memory was. Let's stop it. Let's just build it to memory. See where the characters, the keyboard scan numbers were. Whoops. Pen gone flying. Right. Macros, maths. Oh, here we go. So 40C2. 40C2. Debug program 40C2. So we need to look at memory locations 40C2. We'll get them up and we'll see which ones are changing. Right. See if we can get this bigger so you can see it. So we're trying to find 40C2. Right, 40C2. So it's this lot here. Alright. So let's press fire. Go on easy. Right, can you see they're all FFFFFs? So which bytes move changing? Oh. So I'm looking at the wrong one. Hang on, bit 7. Space is... Well, I've gone backwards, haven't I? Because if that's line... Yeah, I've gone backwards. What an absolute wally. I've done them backwards. One, 2, 3, 4, 5, 6, 7. Right, let's do that again. Can you hear that thumping? God, someone's playing some music really bad. And that's not debugging because I'm on the wrong place. Right, let's blow this up so you can see it. Right, press fire, easy. Just we're going to have to do that keyboard check on here as well. Right, so 40C2, 40C2, come on, 2000, 3000, 4000, 40C2, which is there. These lot, this lot here. Right. Come on. 7. F. 7F. Where's my calculator? F is bit 7, which is right. Right. So back to here. EF is bit 5. Not 4, that's 5. Okay, and let's do the spacebar while we're here. EF bit 5. Right, so that's 5, and that's 5. Right, let's see if we can fix this Game Lander. So we're talking not that one, not that one, we're talking that one, and this one is that one, not that one, and that one, not that one. Right, let's run this properly. F5. Easy. Right, left and right. So, comma and... Right, here we go. Left. Right. Oh. Oh. Did I forget to change the index? Oh, at least I got the spacebar working. Right, that's the spacebar. Spacebar. Right. So I need to make sure that the... This is... Oh well. You could tell it wasn't rehearsed, can't you? We're not doing too bad. I never thought I'd get it working. Never thought I'd get it working. Right, so this should fire the debugger up, which it is. So I need to work out what byte index it was. So CO40C, this is it. There we go. So click on that, press fire. Easy. Right. So I said byte 4 and it's not. It's 1, 2, 3, 4, 5, 6. Byte 6. Okay, byte 6. We'll do the same for here as well. Put a space at the end as well to blank out just in case. Right, F5. Easy. Right, here we go. Oh. I bet I've miscounted again, didn't I? I bet you're all shouting at the screen going, John! I bet it's byte 5. Bet it's byte 5. Sorry guys if you're shouting at the screen. See, there we go. Bet it's byte 5. Zero, 1, 2, 3, 4, 5. Oh God, dear. I'll get this right. I've got it written down byte 5. Oh, what a plank. Oh, so annoyed. Here we go. Come on. Ring keyboard mode. Ring keyboard mode. Come on. Left. Yay! Right. Yay! Left and space. Yay! Right and space. Yay! Oh my God. So much effort. So much effort. Ah! God, an hour and 6 minutes. Right. So, the basic concepts of the keyboard routing is working. And I've got it working in debug mode. So what I'm going to do is, I'm going to call it for this episode. And I'm going to finish it off. I'm going to put the keyboard commands into the main game as well. And put the question, you know, what do you want to use on as well. And then in the next episode I will talk us through, I'll spend the first 10-15 minutes talking about what I did and how I did it, and then we'll move to the next subject, which has been suggested by a patron. So we'll get to do that, but it's working. Look, 2 keys at the same time. 2 keys at the same time. I wonder if it does left and right. Left and right makes it stop. Well, it's working. Look. Right. Okay. If you like what I do, hit that like button. If you didn't like what I do, fine. Hit the dislike button. Always leave me a comment, because I try and answer more. And if you'd like to support me in any way you can, please consider becoming a patron of mine. My lowest one is $1, the highest one is a lot of money, and it's just so that I can keep producing this sort of stuff and use it, and that money just is used for this channel, nothing else, just used for channels. So I've just bought some Python books and stuff like that so we can do the Hunchback series. Right, and with that, I'll see you in the next episode. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.